Okay? Now, when we discuss about the phosphorus, we always mean the white phosphorus because that is the form which is the most reactive form. Now, what are the sources in which the phosphorus is present in a mineral? Calcium phosphate, which is called phosphorite or apatite, and 3 moles of calcium phosphate with 1 mole of calcium fluoride is called fluoapatite. With 1 mole of calcium chloride is called chlorapatite, and 1 mole of calcium hydroxide is called hydroapatite. And the hydroapatite is found in our tooth enamel, that they are present in the tooth enamel. There are 2 methods I have mentioned here, that when you heat calcium phosphate to 14 to 1500 degrees Celsius along with silica, sand, the calcium phosphate reacts with silica to form calcium silicate, which is a slag, and P4O10 is generated. P4O10 is reduced by carbon to give you white phosphorus, and carbon monoxide goes out in the form of a gas. Second method involves calcium phosphate with sulfuric acid, which generates calcium sulfate is a precipitate, is a sparingly soluble sulfate. Phosphoric acid is formed, which on heating gives you metaphosphoric acid. So this is called orthophosphoric acid, this is called metaphosphoric acid. So orthophosphoric acid, so what is the difference between orthophosphoric acid and metaphosphoric acid? Is there are 3 hydroxy group in orthophosphoric acid. Whereas in a metaphosphoric acid, there is only 1 hydroxy group present. So orthophosphoric acid on heating at 320 changes to metaphosphoric acid, and metaphosphoric acid when heated with carbon first undergoes conversion to P4O10 with elimination of 2 moles of water, and P4O10 on reduction with carbon you get carbon monoxide, which is a gas, and P4. Now, phosphorus is a reducing agent. It reduces copper sulfate to copper, which yesterday you have done that reaction, that copper sulfate plus phosphorus plus water gives you copper, phosphoric acid and sulfuric acid. Copper to copper 2 plus. Copper 2 plus to copper is a 2 electron change, whereas phosphorus to phosphoric acid is a 5 electron change. There are 4 phosphorus, so 20 electron change. So I need 10 moles of copper sulfate. And how many hydrogen? 4 3s are 12. 12 plus 20, 32. So I need 16 moles of water. It reduces silver plus 2 silver, gold plus to gold, and phosphorus goes to phosphoric acid. So when white phosphorus reduces silver ion to silver, metallic silver, or gold plus to metallic gold, it gets oxidized to phosphoric acid. So one is a 1 electron change, another is a 5 electron, 20 electron change. So you require 20 moles of silver nitrate per mole of white phosphorus. Phosphorus, when you heat it with magnesium or calcium, you get calcium phosphide or magnesium phosphide. So, you need 2 moles of calcium phosphide will be formed, or 2 moles of magnesium phosphide will be formed. So, you need 6 moles of magnesium or calcium. And this phosphide, when you react with water, will give you calcium hydroxide and phosphine. Magnesium will give me magnesium hydroxide and phosphine. Just like a nitrite gives ammonia, phosphide gives phosphine. Phosphorus with nitric acid will give you 4 moles of phosphoric acid, 20 moles of nitrogen dioxide, and 10 moles of water. Similarly, phosphorus with sulfuric acid, concentrated sulfuric acid, will give me 4 moles of phosphoric acid, 10 moles of sulfur dioxide, and water. So sulfuric acid, sulfur is plus 6, it is plus 4. So it's a 2 electron change. So I need 10 moles of sulfuric acid, because for phosphorus 0 going to plus 5. So 4 moles of phosphoric acid will involve 20 electron change. So sulfuric acid involves 2 electron change, so 10 moles of sulfuric acid will give me 10 moles of sulfur dioxide and the remaining moles of water. How many moles of water? 12. 4 moles of water. Just count the number of hydrogen atoms. Okay, this is the structure. P double bond O is a 143 picometer, whereas P single bond O is 160 picometer. So there is a distinct difference in bond length between PO at the terminal and the bridging PO. Now, how many sigma, how many pi bonds are there? What is the number of sigma bonds in P4O10? Huh? 16 Okay. So remember, one of them is sigma, another is pi. That is the only thing you have to remember. That in a double bond, one of them is sigma, another is pi. Okay. Now P4O6, there is a lone pair on each phosphorus. And phosphorus is trivalent. Whereas here, phosphorus is pentavalent. P4O6, soft, white solid with a Garley coder. So you are saying that 2 phosphorus compounds shows Garley coder. One is a white phosphorus, another is P4O6. It bonds in air to form P4O10, and that is what I have shown here. That P4O6 bonds in air to get converted into P4O10. P4O10 is a white deliquescent crystal. It is a, or you can say solid. It is a dehydrating agent. That means which abstracts moisture. which removes water from the compound, the other partner. I will give you the reaction of P4O10 as a dehydrating agent. For P4O6, when you add to cold water, you get phosphorus acid. The new nomenclature of phosphorus acid is called phosphonic acid. So phosphonic acid and phosphorus acid, they are the same compound. And these are, so phosphorus acid is a diabasic acid. The two hydroxy hydrogen are replaceable and not the pH hydrogen. This pH hydrogen is not an ionic hydrogen. So it is a diabasic acid and it forms two series of salts by replacement of the H of OH group. P4O6, when you add to hot water, you get phosphine plus phosphoric acid. Phosphorus acid undergoes disproportionation when you put into hot water. So P4O6, how many moles of phosphoric acid, how many moles of phosphine? 3 plus is going to 5 plus and is going to minus 3. So one is involves 6 electron change, another involves 2 electron change.
Yes.
So what will be the mole proportion?
1:3.
So 1 mole of phosphine with 3 moles of phosphoric acid.
Yes.
P4O10 with cold water will form metaphosphoric acid. And the sodium salt, NaPO3 N times, a polymer is called calgon, which is used for water treatment. Calgon is used for softening of water. The sodium ion is replaced by calcium or magnesium. With hot water, it forms orthophosphoric acid. It's a tribasic acid. It forms 3 series of salts by replacing 3 hydrogens. So you get NaH2PO4, you get Na2HPO4, and you get Na3PO4. These two are acid salt because the H is present. The hydrogen is acidic hydrogen. So these two salts are acidic salts and this is a neutral. But the aqueous solution of sodium phosphate is strongly alkaline because 1 mole of sodium phosphate on hydrolysis gives 1 mole of phosphoric acid and 3 moles of sodium hydroxide. Now, sodium hydroxide is a very strong base, so this solution is strongly alkaline. So you can see that P4O10 as a dehydrating agent, it removes a molecule of water from nitric acid, converts into N2O5. It removes a molecule of water from sulfuric acid to form sulfur trioxide. It removes a molecule of water from acetamide. It is called acetamide. Acetamide, in presence of P4O10, will release a molecule of water and converts into methyl cyanide. Phosphorus acid, because there is a pH bond present in phosphorus acid, because of the presence of the pH bond, it shows reducing behavior. So phosphorus acid, if you take silver nitrate, phosphorus acid plus water, you get metallic silver You get phosphoric acid and you get nitric acid. So phosphorus acid acts as a reducing agent. It reduces silver plus to metallic silver, gets oxidized to phosphoric acid. The nitrate ion converts into nitric acid. This 3 plus going to 5 plus. So it's a 2 electron change. So 2 moles of silver nitrate, 2 moles of silver, 2 moles of nitric acid. So how many? 2 hydrogen plus 3 hydrogen, 5 hydrogen. 5 hydrogen. Mercury chloride will change to mercurous chloride. So phosphorus acid reduces mercury to mercurous, and mercurous ion always to be written as Hg22 plus, never as Hg plus. Remember that the mercurous ion to be represented as Hg22 plus. So it is a 2 electron change. Each mercury is getting Hg2 to going to plus 1. So it's a 1 electron change per mercury. There are 2 mercury, so 2 electron change. This is also 2 electron change. So 2 moles of mercury chloride will give you mercurous chloride, phosphoric acid and hydrochloric acid. Okay? This is known as calomel. It will give you a white precipitate of mercurous chloride, which is calomel, is a standard electrode, reference electrode. Phosphoric acid does not show any reducing property because there is no pH bond in the phosphoric acid. So phosphoric acid will not be a reducing acid, whereas phosphorus acid will be a reducing acid. Hypophosphorus acid or phosphinic acid, they are the same. So if I take barium salt of barium hypophosphite and add sulfuric acid, I get barium sulfate, a white precipitate, and hypophosphorus acid. The hypophosphorus acid, when you evaporate at 0 degrees Celsius, it comes out in the form of a colorless crystal. It has a melting point 26.3 degrees Celsius. It is a monobasic acid and is a reducing agent. Since there is only one hydroxy group present, so it is monobasic. And since there are a hydrogen attached to phosphorus, that gives the reducing behavior to phosphorus acid.
Yes.
So phosphorus acid reduces copper 2 to copper. It reduces copper 2 to copper plus. It reduces H plus to H minus. Remember that. It reduces silver plus to metallic silver. It reduces gold plus to metallic gold. It reduces mercury ion to mercurous ion, and with excess of phosphoric acid, with excess of H3PO2, it goes to mercury. Okay?
Okay. Yes.
Now you have to balance a reaction. Copper sulfate, H3PO2 plus water gives CuH, H3PO4 plus sulfuric acid. Now you give me the balance reaction. X, Y, and Z, and M. Look at the oxidation state change of phosphorus. That will tell you how many moles of hypophosphorus acid will be required. 4.
4 electron change.
4 electron change. Okay. How many electron change here?
1 3 electron change.
I have
5 electron.
I have given you this.
5 electron change.
That this is a 2 electron chain and this is a 1 electron chain.
5 electron change.
So it is a 3 electron chain.
And 2 H.
Copper 2 going to copper 1, 1 electron change, and H plus going to hydride, 2 electron change. So total number of electron change is 3, not 5. That is 3.
So H2O, there are 2 hydrogen atoms, right?
H plus is going to H minus. So 4 moles of copper sulfate, 3 moles of H3PO2 will give me 4 moles of copper hydride, will give me 3 moles of phosphoric acid, and will give me 4 moles of sulfuric acid. That's all. Only trick is H plus is going to H minus, and that is a 2 electron change. So the total electron change is 3 and not 1 or 5. Now, mercury chloride, 4A, 1H3, and then 4 8 chloride. There are 4 chloride. So you will have 4 HCl. Why 5 HCl? Okay. Now we go to, so that's all about the oxy acids of phosphorus. That is phosphoric acid, which is a non-reducing acid. It is a tribasic acid because there are 3 hydroxy groups present. Each oxyacid of phosphorus will have P double bond O. This is present in all cases. So, phosphorus acid will have 1 OH group. Hypophosphorus acid will have 1 OH. Phosphorus acid will have 2 OH. And phosphoric acid will have 3 OH groups. And that makes the basis monobasic, dibasic, tribasic. Phosphorus and hypophosphorus, they have a pH group, pH bond present. That makes it reducing in nature, not phosphoric acid.
Excuse me, sir.
Yes?
So at room temperature, H3PO2 is liquid or gas, since its melting point is very close to room temperature?
I told you that its melting point is 26.3. So below 26.3 it's a solid. Above 26.3 it's a liquid. 26.3 and above is a liquid. Is it
In
clear?
standard state, we obtain it as a liquid or a solid from nature.
At room temperature. At room temperature you get a liquid. If your room temperature depends upon what is your room temperature. If your room temperature is 30 degrees, you will get a liquid. But if you dry freeze it, that means you are freezing at a low temperature, then you will get a solid. But as soon as you heat it to 26.3, it will melt and you will get a liquid. As soon as I write P4, that indicates white phosphorus. Because red and black phosphorus, they are polymeric form of phosphorus. There we will not write P4. hypophosphites are used in medicine, and P32 isotope is used in leukemia treatment. Treatment of leukemia, that is a blood cancer. Phosphorus 32 isotope is used in the treatment of leukemia. Phosphorus trichloride with lithium hydride will give me phosphine plus 3 moles of lithium chloride. So these are the three methods by which you can prepare phosphine.
Yes.
Take white phosphorus, heat it with calcium or magnesium, you get calcium phosphide or magnesium phosphide. You react with water, it will give you metal hydroxide and phosphine.
Yes.
Second method is white phosphorus. When you react with sodium hydroxide, it gives you sodium hypophosphite and phosphine. Red phosphorus does not react with sodium hydroxide. Yesterday I mentioned to you. And phosphorus trichloride, when you reduce with lithium hydride, you get phosphine and lithium chloride. And phosphine is a gas. There are two compounds which are the odor of which is related to fish. One is ozone, which has a fishy smell, and phosphine has a rotten fish smell. Just like H2S has a rotten egg gas, rotten egg smell. If you take ammonia and dip red litmus paper, it will turn blue. But phosphine aqueous solution, if you put dip litmus, it will not turn blue because it is less basic than ammonia. But it reacts with a strong acid. So a weak base will react with a strong acid to form salt. So phosphine, when you react with hydroiodic acid, among the hydroiodic acid is the strongest acid.
Yes.
So it will react with a weak base to form a salt, phosphonium iodide. Phosphine, it burns in oxygen to give you P4O10 plus water. So phosphine burns in oxygen, in air, to give you P4O10 and water. Pure phosphine is not flammable, but P2H4, the impurity, which is formed along with phosphine, is highly flammable. So pure phosphine will not catch fire. But when you prepare phosphine, along with phosphine, some impurity like P2H4 is formed, and which is highly flammable. So you see that phosphine is burning is not due to phosphine, it's due to its impurity P2H4. Ammonia is not reducing, but phosphine is a reducing acid, as a reducing gas. Phosphine reduces copper 2 to copper and gets oxidized to phosphorus. So it reduces copper 2 to copper, silver plus to metallic silver, gold plus to metallic gold. Is the reaction balanced or not?
Balance.
4 3s are 12, 6 2s are 12. That's all. Okay. Now we move on to sulfur dioxide. So remember that phosphine is a reducing hydride, not ammonia. Don't forget this reaction. This is very important. This is unique. No other metal salt will give this type of oxides, mixed oxides of sulfur.
Yes.
Sulfur dioxide is responsible for acid rain. Sulfur dioxide is a colorless gas. It is soluble in water to give you sulfurous acid. So sulfur dioxide in water, remember it is an acid. So when permanganate reacts with sulfur dioxide in presence of water, don't write MnO2 as a product. You write Mn2 plus as a product because it is acidic. It's an acidic oxide. 2 moles of KOH will react with sulfur dioxide to give you K2SO3 plus water. Base reacts with acid to give salt and water. So unless sulfur dioxide is an acidic oxide, why should it give salt and water with a base? Sulfur dioxide can act as a reducing as well as oxidizing agent. So as an oxidizing agent, magnesium plus sulfur dioxide will give you magnesium oxide plus sulfur. Stannous chloride plus sulfur dioxide plus water gives you stannic chloride plus sulfur plus water. So sulfur dioxide to sulfur is a 4-electron change.
Yes.
And this is a 2-electron change. So I need 2 moles of stannous chloride to give me 2 moles of stannic chloride. This requires 8 chloride, so I need 4 HCl. Okay. So these are the reactions which show sulfur dioxide as an oxidizing agent. The majority of the reaction shows sulfur dioxide as a reducing agent. Permanganate ion plus sulfur dioxide plus water. What will be the product?
Mn2 plus.
Sulfuric acid, dichromate ion plus sulfur dioxide plus water will give you chromium 3 plus sulfuric acid.
Yes.
But if I write full form, okay, yesterday someone asking me about sulfur dioxide with chlorine and water. As I mentioned that sulfur dioxide is an anti-chlor.
Yes.
Hydrogen peroxide, sulfur dioxide, and sodium thiosulfate, these 3 agents are anti-chlor agents. And this gives me H2SO4 plus HCl. So this as an anti-chlor, sulfur dioxide plus hydrogen peroxide gives me sulfuric acid. Only one product. This is called a total consumption reaction. Sulfur dioxide, if I dissolve ferric chloride in water, I get a yellow solution. If I pass sulfur dioxide, the color vanishes due to ferrous chloride, sulfuric acid. Ferrous chloride is almost colorless, sulfuric acid is colorless, so the yellow color vanishes. And Since you have 3 chloride, you have 2 chloride, so we will have HCl. Now sulfur dioxide to sulfuric acid is a 2 electron change. Ferric to ferrous is a 1 electron change, so I need 2 moles of ferric chloride will give me 2 moles of ferrous chloride, 2 moles of HCl.
Yes.
So I need 2 moles of water. Sulfur dioxide will turn starch iodate paper. This is a very characteristic reaction exhibited by sulfur dioxide. It distinguishes H2S, sulfur dioxide from H2S. H2S is reducing. Sulfur dioxide is also reducing. H2S will discharge permanganate color in presence of acid to give you Mn2 plus. Sulfur dioxide plus water will discharge MnO4 color to give you Mn2 plus. H2S will turn dichromate paper green. Sulfur dioxide will turn dichromate solution green. So both will give similar test. But sulfur dioxide will turn starch iodate paper iodate solution blue, which H2S will not do. Balance this equation. Y2, Y2. You have only one I2I, Y2, Y2. Only iodine. You have 5 sulfur. You have 2 sulfur here. 2 plus 6, 8, 4 out 2. So you see what happens. The sulfur dioxide reduces iodine 5 to iodine 0. So sulfur dioxide reduces iodine to iodine. Iodine reacts with starch to give you starch iodine complex, which is blue in color. And this is a very, very special test for sulfur dioxide. So when you pass chlorine over sulfur dioxide, you, in presence of ferric chloride as a catalyst, you get SO2Cl2, which is called sulfuryl chloride. And when you react sulfur dioxide with PCl5, you get ionyl chloride, just like phosgene. COCl2 is called phosgene, SOCl2 is called ionyl chloride. So that's all about sulfur dioxide. Sulfur dioxide bleaches the dye by reduction. It reduces the dye to a reduced form, and if the reduced form of the dye is colorless, so it bleaches. But atmospheric air will further oxidize the product, and that is why it is temporary. So the bleaching by reduction is temporary because atmospheric air will bring it back to its oxidized form, and which is colored. Sulfur trioxide. Sulfur trioxide is used for preparation of alcohol, sulfuric acid. So when you pass sulfur trioxide to dilute sulfuric acid, the water present in dilute sulfuric acid reacts with sulfur trioxide to convert sulfuric acid. And this process is called contact process, where nitric oxide is used as a catalyst. It is known as Chambers process, which is also again used for preparation of sulfuric acid. Sulfur trioxide is a solid at less than 17 degrees Celsius. It exists as a linear chain or a cyclic trimer. It exists as a linear chain polymer or as a cyclic trimer in chair shape conformation. Now you can see here that sulfur trioxide oxidizes P4 to P4O10. It oxidizes HBr to bromine, HI to iodine. But it could not oxidize HCl to chlorine. So sulfur trioxide is not strong enough to oxidize HCl to chlorine, but is strong enough to oxidize HBr to bromine or HI to iodine. And that is why it forms chlorosulfuric acid. Sodium thiosulfate. Can you read it?
Yes.
Sodium thiosulfate pentahydrate is known as hypo. It's a very important compound. It is used in photography. Sodium thiosulfate can be prepared sodium sulfide plus sulfur. When you boil, you get sodium thiosulfate. Number one. Number two, sodium sulfide plus iodine plus sodium sulfide gives me sodium iodide plus sodium thiosulfate. React these two. You get sulfur plus 2 sodium iodide. Sulfide is a reducing agent. Sulfide reduces iodine to iodine, gets oxidized to sulfur. This sulfur reacts with sodium sulfide to give you sodium thiosulfate. So, in the reaction, I am generating sulfur. I have not taken sulfur externally. I am generating sulfur during the course of the reaction, and which reacts with sodium sulfide to give you sodium thiosulfate. Sodium sulfide plus sulfur dioxide plus sodium sulfide. Sodium sulfide plus sodium sulfide plus sulfur dioxide gives me only one product, sodium thiosulfate. How it is forming? How do you get sodium thiosulfate? So first you react sulfide, sulfur dioxide oxidizes sulfur, sulfide to sulfur. Sulfur dioxide gets reduced to sulfur. So sulfur dioxide oxidizing sulfide to sulfur, getting reduced to sulfur. Sodium oxide now reacts with 2 moles of sulfur dioxide because I have taken 3 moles of sulfur dioxide. I have used 1 mole here. So I react with this to generate 2 moles of sodium sulfide. And I have already 1 mole here. So I get 3 moles of sodium sulfide plus 3 moles of sulfur. Okay, can you do this reaction? The product is 1 mole. How many sodium? How many sulfur? 3. Now how do you get sulfite and thisulfate. Look, this is 4Na goes to 4Na plus. They will write 4Na plus 3 sulfur dioxide to give you sodium sulfite plus sodium thisulfate. How it forms? That is what you have to show like this. That sodium metal goes to sodium ion, releases 4 electrons, and 4 electron reduces sulfur dioxide to sulfur. The oxide ions are released. Sulfur dioxide has 2 oxides. So sulfur plus 4 goes to 0, oxide ions are released. 4 sodium ion combines with 2 oxide ions to give you 2 sodium oxide. That reacts with 2 moles of sulfur dioxide to give you sodium sulfide. And 1 mole of sodium sulfide reacts with 1 mole of sulfur to give you sodium thisulfate. That is why I said 1:1. How will you prepare sodium sulfide? You can react with sodium oxide plus sulfur dioxide to give you sodium sulfide, or sodium hydroxide plus sulfur dioxide to give you sodium sulfide plus water. When you evaporate, you get sodium sulfide solid. Okay. Sodium thisulfate. Now, sodium thisulfate, when you react with acid, what is the structure of sodium thisulfate? There is a sulfur-sulfur bond present in sodium thisulfate. And when you add acid, the sulfur-sulfur bond gets broken, gets cleaved, and the sulfur is precipitated. The H plus, the sodium salt, Na2SO3, is it Na2SO3? Na2SO3 plus HCl gives me sodium chloride plus H2SO3. H2SO3 is nothing but sulfur dioxide plus water. So I have written this. Sodium thisulfate. The oxidation state of sulfur in sodium thisulfate is a matter of controversy. Some authors say that this is 6, this is -2, or 4 and 0. Normally, the sulfur-sulfur bond is taken as 0. Only in sodium thisulfate, it is the 2 oxidation states have been proposed. One 6 and -2, another 4 and 0. So, you must know that these are the matter of controversy in case of sodium thisulfate. Sodium thisulfate. Sodium thisulfate shows 2 different properties. It acts as a reducing agent, it acts as a complexing agent. Sodium thisulfate, when you react with iodine, you get sodium tetrathionate plus sodium iodide. How can I get 4 sulfur from 2 sulfur? So I have to multiply by 2 to get Na2S4S7 plus 2 sodium iodide. Okay?
Yes.
Sulfur, what is the oxidation state of sulfur in sodium thisulfate? Is it 2 plus or 3 plus?
2 plus.
What is the oxidation state of sulfur here?
5 by 2.
So 2.5. 2.5. So per sulfur, there is a 0.5 electron change. So 4 sulfur will have 2 electron change. And iodine, 2 electron gives 2 iodide ion. So I need 2 moles of sodium thiosulfate per mole of iodine to give you sodium tetrathianate and sodium iodide. Now these both are colorless. So when you add starch, the iodine reacts with starch to give you the blue solution. When I add thiosulfate from the burette, at the end point, thiosulfate gets converted to sodium tetrathianate. Thiosulfate is a colorless. So solution will be colorless. If the solid is colorless, then solution will be colorless. Iodine plus starch gives blue color. When I titrate with sodium thiosulfate, the iodine gets converted to iodide, which is colorless. Sodium tetrathianate is colorless. And starch is also colorless. So your end point will be colorless. So the blue solution will change into colorless end point. So sodium thiosulfate is used for estimation of iodine. In presence of starch, it will give blue color, and when sodium thiosulfate oxidizes, reduces iodine to iodide. So what is the role of sodium thiosulfate here? As a reducing agent. It reduces iodine to iodide. So it acts as a reducing agent. And it gets oxidized. 2 goes to 2.5. So sodium thiosulfate is oxidized. Sodium thiosulfate reduces iodine to iodide. So sodium thiosulfate is acting as a reducing agent. Okay?
Excuse me, sir.
Bolo?
So is there a way of preparation of sodium sulfite from sodium thiosulfate?
Sodium?
Sulfite from thiosulfate.
Sodium thiosulfate, what you have to do is difficult. You can do it in an indirect manner. Sodium thiosulfate, when you add acid, what happens? Sulfur dioxide is eliminated. The gas, if I pass to sodium hydroxide, I get sodium sulfite.
Sir, but the sodium are replaced by the H positive now. Then we get H2SO3 formation.
H2SO3 is not stable. It changes to water plus sulfur dioxide. Sulfurous acid is not a stable acid. So it changes to sulfur dioxide and water. The sulfur dioxide gas comes out. You pass the gas into alkali, sodium hydroxide, you get sodium sulfite. Is it okay?
Yes, sir. And sir, during this, when the S double bond is broken,
Yeah.
what happens to the S which removes out? Does it form another molecule or?
No. That is a colloidal sulfur. The solution becomes turbid due to colloidal sulfur, which is insoluble in water. This is the structure of Na2S4O6. What is the oxidation state of sulfur? There is no ambiguity. There is no controversy. This is 5, this is 0, this is 0, this is 5. Because this sulfur forms 5 bonds, so it is 5. This sulfur forms 5 bonds, so it is 5. This sulfur bond is taken as 0. Okay?
Yes.
Na2S2O4. sodium diethionite. This is another compound where sulfur-sulfur bond is present. This sulfur forms 1, 2, 3 bonds. So it is 3. This 1, 2, 3, it is 3. So you see in this case, the sulfur-sulfur bond is taken as 0. Only the number of bonds which form with other elements, that is counted. So only in sodium thiosulfate, there is a controversy, but not in other cases. Another is called Na2S3O9, sodium tetrathionate, trithionate. So there is no controversy. You see the sulfur-sulfur bond is taken as 0. Only in sodium thiosulfate, there is a controversy. Now, if both the options are given, 6 and -2 or 4 and 0, if both options are given to you, I will go by 4 and 0 and not 6 and -2. But if only one option is given, 6 and -2, then you tick mark 6 and -2 for sodium thiosulfate. Because both are accepted. Sodium thiosulfate as a complexing agent, silver bromide plus sodium thiosulfate gives you silver thiosulfate. When you add excess of sodium thiosulfate, you get, it acts as a complexing agent. Okay? The oxidized product of sodium thiosulfate is always sodium tetrathione. There is no other oxidized product. Na2S2O3 will always go to Na2S4O6. Thiosulfate is reducing Au3 plus to Au1. Is a reduction.
Yes.
And then excess of sodium thiosulfate. So you see that how sodium thiosulfate is playing two roles. First is reducing gold 3 to gold 1. In the second case, it forms a complex with gold 1. Sodium thiosulfate, cyanide ion. Cyanide is reducing copper 2 to copper 1. And with excess potassium cyanide, it gives K3CuCN4. Still copper is in 1. So it's a complexing agent. So the cyanide is also playing like thiosulfate, a reducing complexing agent. When you add sodium thiosulfate to ferric chloride, sodium thiosulfate reduces ferric to ferrous, gets oxidized to sodium tetrathione, and sodium chloride is formed. All are colorless. So the yellow color vanishes when you add sodium thiosulfate to ferric chloride. Sodium thiosulfate, if you heat it, you get sodium pentasulfide plus sodium sulfate. Give me the value of X, Y, and Z. Calculate the oxidation state of sulfur. What is the oxidation state of sulfur here?
Plus 4.
What is the oxidation state of sulfur here?
-4.